Okay, this may end up having to be broken up into three parts. So this next part we're going to focus on estimating the sums and differences of numbers, modeling adding and adding mixed numbers, modeling subtracting and subtracting mixed numbers, and then we're going to see if we can make another one on the application of these skills in word problems. So let's get started on the first one, which is going to be estimating sums and differences of mixed numbers. So essentially our estimate, what we're going to do when we're estimating, we are going to be using our number line again. We're thinking of our number line, and in this case we have 2 1/4 and 1 5/8, and I'm going to use my number line to show you how to do this. Okay, so our problem is 2 1/4 plus 1 5/8. So 2 1/4. Let's take a look at where that is. So there's two different ways you can do this. You can do it just by looking at the whole number. So here's where 2 1/4 is. So and here's 1 5/8. So you would say which whole number is it closer to? Again, 2 1/4 is between 2 and 3 on the number line. So we would say it's close to 2. And 1 5/8, we would say this one is close to 2 also. So 2 plus 2 equals 4. The other way we can do this is by using this half, the benchmark number, which is 1/2. So I'm going to circle that. I'm going to circle that. So is 2 1/4 closer to 2, 2 1/2, or 3? Well, it's in between these two. So I always tend to want to round up. Again, because a lot of times it's better to have more than you need than not enough. So I tend to round up. So this one, 2 1/4, would probably round to 2 1/2. And when I look at this, 1 5/8 is pretty close to this 1 1/2. 1 1/2. So if I add those up, 1/2 and 1/2 equals a whole plus another whole plus 2 equals 4. So either way, I got 4 as my estimate. So all this lesson is using our number line as we've done before, and we are just deciding whether we can do it two ways. We can look at the nearest whole number only, or we can also use the benchmark and decide either it's near the whole number, the halfway mark, or the next whole number. Those are the two ways that we can estimate with mixed numbers. That's it. The next two lessons involve modeling addition of mixed numbers and doing what we would consider the traditional way of using equivalent fractions and common denominators to add mixed numbers. So I'm going to show you both ways. Okay, so we're going to use the first example that we have in the book of. Okay, so basically what I want to show you here is we have are 1 11/12 plus 2 1/3. I have to convert this 1/3 into 12ths. So I will do that by making sure that I have my 4/12ths, which is going to equal. So what I will do, let me take this third out of here, sorry. So when I am doing this work, I am going to combine these two. So I'm going to bring this together. So I have 3 wholes. I'm going to put this up here. So I have another 1 whole. So I can just kind of put that on top of it. And what's our grand total? It's going to be 1, 2, 3, 4, and 3/12, which would simplify into 4 1/4. So that would be equivalent. Again, that would be simplified. So what does this look in a traditional sense? Let's take a look. Okay, so in a traditional way that we would do this, again, I like to separate the whole number side from the fraction side and figure out the fraction side first. So I know 12 is our denominator. So this is going to be times 4. So this is 4. So I'm going to add this up. I'm going to get 15/12, and this is going to be 3. So when I put this together, I know that this is 12/12 equals 1 whole. So I have 1 whole and then 3/12 left over. So simplified, that would be 1 1/4. and I put that together with the 3. So I have 4 and 1/4, which is exactly what I got over here. Okay, let's look at one more example, and this is 1 1/2 plus 2 3/4. So the model 1 1/2, 2 3/4. We need to convert these halves into fourths, and we know that that will equal 2/4. I'm going to get rid of this half here. All right, so when I combine these, actually, let me just bring this one down. When I combine these, I have 3 wholes, but I also have this one, this fourth that makes another whole. So I'm going to end up with 4. I'm just going to put it under here. 4 and 1/4. So 4 and 1/4 is going to be my final answer, okay? So again, I have 4 wholes and 1/4. Let's see what it looks like when we do it our traditional way. All right, so again, common denominators, we're using 4, so that's 2/4. I have 3/4. Added together, I have 5/4, which equals 1 and 1/4. I put the whole numbers together, 3. So then I mix the 2, I put the 2 together, and I have 4 and 1/4, which is exactly what I had over here. So that is modeling and using the traditional way of finding common denominators and equivalent fractions to add mixed numbers. So it's modeling and adding them. Okay, subtraction of mixed numbers is a little bit more complicated, so we're going to get started a little easier. I'm not going to go with this first problem. I'm going to do a few other problems that we find in there, and I'm going to point out some of the differences that makes subtracting of mixed fractions a little bit more complicated. All right. Okay, in the first example, I have 4 and 5/6 minus 2 and 1/3. So I would have to convert these to thirds and see how many sixths that is. So I know that 1/3 equals 2/6. So let me ask you a question. Do I have enough sixths to take 2 of them away? So could I take 2 of them away? Sure. So to be honest, when we are doing modeling, we really don't have this. We just have to be able to picture it in our head. Do I have 2/6 to take away from here? Sure I do. So let's actually take away this 2 and 2/6 from here. So that's gone, and let's take away 2/6. What does that leave us with? 2 and 3/6. 2 and 3/6, which we know is 2.5. So 2.5 is our answer. So let's do it the traditional way. We know we're going to use 6 as our common denominator. So this is going to be 2/6. We subtract it, we get 3/6. We know that's equal to 1/2. And on this side we have 2. Put it together and we have 2.5. That's one example. Okay, so our next example is 2 3/8 minus 1 1/4. So let's convert the 1/4 into eighths. And I know that equals 2/8. So let me ask you a question. If I have 3/8, will I be able to take 2/8 away? Sure I will. So remember, I don't really need to have 2 different models going. I just need to know that I have enough eighths to take away. So let's do the math. So we have 2 3/8. Let's take 1 whole, and let's take 1/4, which is 2/8 away from here. So 2/8 are gone. So that leaves me with 1 and 1/8. So let's see the traditional way. I'm using 8 as my common denominator. So this is going to be multiplied by 2. So 1 times 2 is 2. Subtract it. I get 1/8. So 2 minus 1 is 1. My answer is 1 and 1/8. There you go. So the next two are going to be a little different, and I want you to notice the difference. Okay. So this next one. Okay, this one looks a little different, doesn't it? It doesn't look like I'm going to have enough twelfths to take away from here. So I have to convert 1/2 into twelfths. So let's do that. Okay, so I know that that equals 6/12. But I know I do not have enough 12ths. So what I'm going to do is I'm going to take 12/12. I'm going to take one whole. I'm going to convert it. I'm going to take 12/12, and I'm going to use that. So I'm going to put these up here. I'm going to get rid of some of these other things here. Okay, so when I take a look at this, how many 12ths do you see? 12/12 and 6/12. There's 18/12, right? So remember, when I'm doing this work, I actually don't have to have this hanging around. It's just useful for me to kind of just visualize. So I need to take one whole, so that's going, and 11/12. So all these are being subtracted. So what does that leave me with? That leaves me with these. This right here. And that how many 12ths is that? 1, 2, 3, 4, 5, 6, 7 12ths. So let's see what that looks like with our traditional way of doing things. Okay, so this is going to be 11. This is going to be 6. But I'm going to convert. I'm going to take 12/12 out of here, so it's not going to be 2 anymore. And I'm going to put 12/12 with that, plus 12/12. Okay, and that's going to give me 18/12. So now I can do 18/12 minus 11/12 equals 7/12, which is exactly what I got for the top number. Let's do another example. Okay, one more example to show you how when we're going to have to regroup. Okay, so do I have enough to take away here? So let's convert these 3/4 into eighths. Right, so we're going to say that that is going to be 6/8. Okay, so we do still have to find our common denominator. So when I look at that, do I have 6/8 to take away from here? Absolutely not. So I'm going to have to regroup. At this point, I really don't need this example anymore. So I'm going to take one of these whole numbers, and I'm going to regroup it. And put that away, and I'm going to get 8/8, and I'm going to put it over here. So how many eighths do I have? I have 9/8. So now let me ask you, can I take 6/8 away? Sure I can. So let's do the actual problem. So here's what I have. I have to take 3 wholes, because again, here's the problem. 4 1/8 minus 3 3 3/4. Take away 3 wholes. Take away the 3/4, which was 6/8. 1, 2, 3, 4, 5, 6. What does that leave us with? It leaves us with 1, 2, 3/8. So let's see that with our traditional way of doing things. I'm going to use 8 as our common denominator. Again, there's 1/8, and there's 6/8. We know we don't have enough eighths. We can't do this, so we have to take 8/8 away from here and bring it over here. So this is now going to give me 7/8. So I'm sorry, 9/8. 9/8. So 8/8 plus this 1/8 is 9/8 minus 6/8 equals 3/8, which is exactly what I just got over here. Let's look at one more unusual problem that you're going to see, model it, and do the traditional way. So we have 5 minus 2 3/4. Do I have any fractions to take away? No, I don't. So I need to convert. I need to take one of these wholes, and I need to replace it with fourths, because I already know what I'm taking away is fourths here. So now, do I have enough fourths to take away? Sure. So I have to take, so again, once again, I don't really have this. I'm going to use this to take it away. So what do I have? I have to take away 2 3/4. So let's do that. 2 3/4. That leaves me with 2 1/4. 2 1/4. So how am I going to do this the traditional way? Again, I am going to convert this 5 into 4 4/4. So here's my 4/4 over here. So I'm going to subtract that, get 1/4, and 4 minus 2 is 2. 2 1/4 is the final answer.